In this lecture, our workers will start to be animated as they move around and gather supplies. Let's get started. For animation synchronization, we have a couple of options. The first one is on our abstract unit. In the update function, we can set animator parameters. This requires a little bit more work to synchronize actions when they happen within the behavior action. For example, attacking is probably done with a trigger, and there needs to be some kind of cooldown. So there's a lot more work to synchronize exactly when that animation should play in our abstract unit, when our behavior action is the one controlling exactly when attacking should be happening. So the next logical option is, well, let's set the animator parameters within the behavior action. This also has some cons to that implementation, because that either requires weird behavior tree branches where we have like its own dedicated do animation stuff running in parallel, or we have to duplicate code in our behavior actions. Based on this, which one do you think that we should pick? We're going to pick option 2. Why is that? Well, RTS games tend to have a large number of units, and having many units with multiple monobehavior update calls quickly results in very poor performance. You'll notice that so far, the only code we've written with any update is to capture player input, and that's going to remain true throughout the rest of the course. The only update calls will be from built-in components. This gives us much more optimized code. So in essence here, we're trading slightly more inconvenient code because we have to duplicate some code. Luckily, it's very simple code. And we're getting significantly more performant code because we're not doing any update calls on any of our mono behaviors. This gives us a pretty well optimized solution without having to go full ECS or entity component system, which is a whole new course on its own. Let's hop over into Unity and take a look at our animator because we haven't really spent much time looking at this so far. We just select a worker and come to the animator, which is under Window, Animation, Animator. We should see the animator for our workers. We only have a couple of important parameters right now. That's speed and is gathering, because those are the only two things that we really do so far. From our idle state, we can transition to a walking blend tree that blends based on that speed parameter between walk and run. So based on that speed, the faster they go, they'll transition over here into a full-on run. And this happens if our speed is greater than a very small number. We'll go to the mining state if we have is gathering true, which is just playing a simple animation. And then whenever is gathering is false, we can transition out of this state to is walking or idle based on our speed. So we can see the primary thing we need to do here is set the speed, and that can change every frame. And that's why we would need to consider doing that in an update function. Our worker has our behavior agent, which runs our actions and generally updates approximately every frame. Not guaranteed to be, but generally around every frame. So in our actions, we can get that same type of behavior to set the speed anytime that we're going to move. Let's open up VS Code and one of our simple movement actions, move to target location. We now know that we need to get an animator, and if it's present, we want to set some values. So let's define a private animator. And we might think that it should go right here on start. If we don't have one, we fail, but that's not necessarily true. We can still do this whole node if there's no animator. It's just probably not going to look very good, but it doesn't result in a failure. Right after that guardian pattern, we can just do agent.value.tryGetComponent out animator. The agent destination will get set. And then on update, we're going to want to check if our animator is not null. If it's not, then we can set our animator parameter for speed. We can do that simply with animator.setFloat speed, which should exactly match what we have in the animator parameters. And we can set the agent.velocity.magnitude, which gives us a scalar value or a float representation of the velocity. And that's all that we have to do. Let's come back into Unity and see how that looks. And remember, this is what's called whenever we right-click to move or issue the move command. So let's hop into the game view, click play, select a worker, and if we send them somewhere, we'd expect them to start running. That's awesome. So now they're running, and once they get to the location, oops, not quite right, because when we end, we didn't set the velocity back to 0. Let's hop back to VS Code. We can just define that protected override void on end. And I'll just copy paste so we don't have to type as much. So we got that if animator does not equal to null, set the float speed to be 0. And that will solve that problem because once we exit this state, we'll go back and set that animator parameter to be idle. And if we happen to transition to another movement state, we'll be overriding it again the same frame, and that's okay. Now we can see that we have multiple references to this magic string of speed. So it'd be nice if we could maybe make this something that we can reuse in multiple locations. SetFloat has an overload where it accepts this ID. This is a significantly faster way of setting animator parameters because when we send a string, it actually converts it to this int using a function called animator string to hash. So if we do animator string to hash speed, that's effectively what happens if we just pass a string. So to make this even faster, it'd be great if we cached an int value that is the return value of this function call. Let's cut that animator string to hash speed and move it to a utility class. In our scripts folder, utilities, let's make a new class, call it animationconstants.cs, put that in our GameDevTV RTS utilities namespace, and make it a public static class animation constants. We're never going to want to make an instance of this. Then let's define a public static int speed in all caps equals animator.string2hash, providing speed as the parameter. And we're going to need a second one up here in a second for isGathering. So let's make that a public static int is_gathering in all caps equals animator.string2hash isGathering. In Pascal case, we'll handle any other ones in the future by just adding new public static ints for each parameter that we'll have. Then back in move to target location action, we can set the speed float with animation.constants.speed instead of the string. So we have the most optimized way of interacting with the animator. That's all that we need to do to set that speed. With that in mind, enter this lecture's challenge. In all of the behavior actions that move the agent, set the animator speed parameter based on the navmesh agent's velocity, just like what we just did. So pause the video, find all of those behavior actions we've implemented so far, and set up the speed so they'll animate properly, regardless of which action is performing the movement. And when you're done, I'll see you right back here. All right, welcome back. I hope you're able to find all of those and implement this. Let's come right into VS Code. In our move to target location action, we know we're going to do this exact same thing. If animator does not equal to null, animator.setFloat, animation constant speed based on the agent velocity magnitude. I'm just going to copy that. And here in our behavior folder, because we're well organized, we can tell by the name of these classes which ones have movement with that move to prefix. Let's start top down, move to gatherable supply action. So at the top, let's go ahead and define a private animator. On start, after our validation, we'll do agent.tryGetComponent out animator. That'll assign our animator if it's present. Then at the top of update, go ahead and set that float on the animator. Looks like there's no on end. Let's do a protected override void on end. And if the animator is not equal to null, we'll set the speed to be 0. That should be all. Let's move to target game object action. One more time. At the top, a private animator. Right after our validation, agent.value.tryGetComponent out animator. And yes, on update, we can paste our animator is not equal to null, import those animation constants. There's no on end, so define protected override void on end. Paste again, and set the speed to be 0. We've already done move to target location. Set agent avoidance. We're not moving the agent in this one, so that's fine. Stop agent. We could be safe here if we wanted to and assign the animator. Let's do it just for fun, but if you didn't do this as part of the challenge, that's totally fine. In here, we don't need a cache or reference or anything like that. Inside of the if, where we're doing agent.tryGetComponent to find the navmesh agent, if that finds one, we'll also check if the agent tryGetComponent out animator. If that returns true, that means we have an animator, and we'll set the speed to be 0 in here. Just a little safety. If we're cleaning up after ourselves really well in all our actions, we shouldn't necessarily need to do this, but it's always better to be safe than sorry. That should be everything we need to do for movement. Let's take a look at it. Come over to Unity and click play. Let's take a worker, tell them to gather. Great, they're running. They stand there because we haven't done the animation for gathering, but they run back and forth on their gather action. So this is working perfectly. Now back into VS Code, gather supplies action is where we actually are gathering the supplies, right? So in here, we're going to need a reference to the animator, right? Let's define that private animator. And the way this works is once we enter, we start gathering. Just before we begin gather, we can do if unit.value.tryGetComponent out animator. And what do we need to do here? Do animator.setBool, because this is a Boolean value, animation constants.isGathering to be true. Since we have on end in here, even before this return of our guardian pattern, we want to make sure that we set that is gathering to be false. Because if we do it afterwards and the gatherable supplies happened to be null because it got gathered, we don't want this to be stuck in the animation of gathering. We want them to go back to their normal running, right? So if the animator is not equal to null down here, we'll set the Boolean is gathering to be false. And that should be all that we need to do. Let's go ahead, come back to Unity and see this fully in action. We'll click play. And just to check every single case here, let's pause, which is Control-Shift-P, find some minerals, set that value to 8. And let's again disable the 2 right next to it so we'll see that agent really move. Come back into the game view, unpause, gather 1, gather 2, perfect. Now we see them enter that gathering state, gather, and run back. Now it's looking a lot better. We probably want to increase the gather time because they don't really spend any time there. So let's do that right before we get out of here. Do you know how to change the gather time? In our project panel, gatherable supplies, minerals, the base gather time of 1.5, let's change that to 4. Same for the gas. Go ahead and click play one last time. Select a handful, tell them all to gather, and we can see them now by their animation what exactly they're doing. So that looks pretty good. In this lecture, we've seen how we can synchronize our animations with our actions in a performant way that doesn't require us to add update loops. When you're ready to move on, I'll see you on the next lecture.